are going to talk about variance. And I will start with a very simple example and we will continue where we left off. And the topic was expected value. So basically, what is expected value? Expected value is the mean of a distribution. It can say a lot about a distribution, but still it's not enough to give a good comprehensive description of the distribution. That's why we need another metric to describe a probability distribution. And one of those things can be variance. Let's start with this example. You have a fair coin and you toss. It's either head or tails, and it has a fair probability. Each one has a 1/2 probability of happening. And let's say you get $1 if it's tails, and you lose $1 if you get heads. In this case, what is the maximum amount that you can put into this game and play? Which is 0. Why? Because we are looking at the expected value. And if we think about it like this, just a second. And I'm going to draw the graph for this distribution. And let's say we have $1 here, minus $1, minus $1, and we have $1 here. So, and both has the same probability, which is 1/2, and the expected value will be roughly this point. Why? Because at this point our graph balances itself. And you can see this is our probability distribution, and expected value is 0. Why? Because as you can see, this is a discrete distribution, and in that case the expected value will be the sum of the product of each value of the random variable multiplied by its corresponding probability. And if you calculate that, it will be minus 1 multiplied by 1/2 plus 1 multiplied by 1/2, which gives us 0. Now let's look at the let's look at another case. In this game, we're going to say, okay, the same thing. You toss a coin, either it's heads or tails, and if it's heads, you lose 100 euros, $100, and if it's tails, you get $100. And in that case, it will be, let's say, let's make it a little bit taller. Maybe it would make a little more sense. Okay, $100, and this is minus 100, and this is $100. And again, roughly this will be the point where the graph balances and its expected value. But you can see in this graph the values are more spread than the first one. And how can we measure how spread is the graph? So what we can do, we can take the expected value, look at the distance, which is 100, whatever it is, expected value, and this is the distance, this is another distance. You can add those up. I mean, these distances, what it is. Let's say this is value 1, this is x2 and x1. X minus x1 plus minus x2. As you can see, this one will be negative and this one will be positive. But actually, we're not interested in the negative or positive value. We're interested in the distance. That's why we can just basically take a mode of this function, because we're interested in the mode. And then we come up with something like this. X, let's say n minus xi in mode. Okay, this would make sense, right? Because the more spread the distribution is, this distance will be more, and then it will reflect itself in our final equation here. So this is a valid metric that we can use to compare how spread the two distributions are. But actually, this is not the formula that they use to calculate the variance of a distribution, because if you use this, it will open up a lot of unnecessary and complex mathematical operations which we don't need. And if we just replace this mode operation with the square operation, we conclude our topic with the final formula for variance. So this formula is used to find the variance of a distribution. So basically, in other words, you can say and there should be n here, right? The number of points. Why we take the n? Because we are interested in the average distance between the points and the mean. And in order to find the average, we have to divide it by n. So then basically it also becomes something like this, right? We again and here, because this is the average means expected value, so we can also describe the whole formula with the expected value. So we are basically looking for the expected value of the distance between the values of random variable and the expected value of the distribution. See you next time.